Hello. An electron is moving around a hydrogen nucleus in a circular orbit. The force between the two is. Observe four options. Vector notation. So you should take care of sign also. Okay. If this is hydrogen atom with one electron negatively charged, with one proton positively charged. Okay, and distance between these two is radius of the orbit r. Then force equal to constant charge of electron, charge of proton by distance square, r square. So there is negative sign. Constant is 1 by 4 pi epsilon naught e square by r square. This is force, magnitude of the force. There should be n cap. If there is n cap, position vector, then this is vector f. Now with r cap there is only one option, but the negative sign is absent. Therefore this is not the option. Answer. Now multiply and divide this by magnitude of r, magnitude of position vector. So product of these two gives vector r into r square is r cube e square with constant 1 by 4 pi epsilon naught with negative sign. Observe, negative sign, vector r by r cube, r by r cube, negative sign, r by r cube, negative sign, but e square is absent. Vector r by r square. Therefore, and the negative sign represents attraction, attractive force. Okay. If the force is between two like charges, then we get positive. Pick out this statement. Pick out this statement which is incorrect. Students, try to underline terms like incorrect, wrong. Okay. Because usually we are tempted to go to the right statement. The electric field lines form closed loop. This statement is wrong. Therefore, this itself is the correct answer. Observe, for positive charge, field lines are radially outward, isn't it? Like this. If it is negative charge, isolated negative charge, then lines of forces are inward, radially inward. They themselves doesn't form closed loops. That is the meaning of this first statement. Field lines never intersect. True, isn't it? This is one of the properties of electric field lines. Statement is correct. Therefore, this is not the option. The tangent drawn to a line of force represents the direction of electric field. True. If we consider a dipole like this, electric field lines are from positive to negative. Positive to negative. These are electric field lines, also called line of force or lines of force. At this point, if we draw a tangent, that tangent represents the direction of electric field. So electric field is along the tangent. So statement is correct. A negative test charge experiences a force opposite to the direction of the field. Statement is correct, isn't it? If this is the electric field, if there is a negative charge, then this negative charge experiences force opposite to the direction of electric field. So this is the direction of force. Observe, these two directions opposite. That is the meaning of this. So second question, first option. Students, you should also observe this. There are so many statements. To read and identify the answer, we need time more than 1 minute. But in most of the exams, in 1 minute we have to solve the question. Pick out the statement which is incorrect. Again, incorrect statement. Electrostatic force is weaker than strong nuclear force. Yes, force electric is always weaker than force due to strong nuclear force. So statement is correct. 2 point charges 4 nanocoulomb and 8 nanocoulomb are separated by some distance in air. Fine. Force on 8 nanocoulomb is greater than the force on 4 nanocoulomb. No. This is the incorrect statement. Therefore, the answer. If this is 8 nanocoulomb and the second charge is 4 nanocoulomb, if these two are like charges, positive, positive, then there is repulsion. Like this, isn't it? So these two are equal and opposite action-reaction pair. Let me write action-reaction. What is the meaning of action-reaction? Forces are equal and opposite. For every action, there is an equal and opposite reaction. Let me denote this force by F12, meaning force on first charge due to second charge, and this is force on second charge due to first charge. So F12 is equal and opposite to F21. Okay. If it is not clear to you, let me explain a little bit. Let us find force on first charge due to second. Coulomb's law. Constant, product of the charges 8 nano 4 nano by r square, isn't it? Now let me find force on second charge due to first charge. Constant, product of the charges 8 nano 4 nano by r square. Observe their magnitudes. They are equal, but directions are opposite. Direction of F12, direction of F21. So they are equal and opposite forces, action-reaction pair. Okay. You don't have to check these two, but still, since it is for practice, let us check. Electrostatic force is greater than gravitational force. True. Two equal and opposite charges are separated by some distance in air. Magnitude of force on negative charge is same as that on positive charge. No. Here also they form equal and opposite. Directions are opposite, but magnitudes are equal. Statement is correct. Therefore, so this is the incorrect statement. A charged particle is placed in uniform electric field. Its path will be straight line, parabola, circle, helix. It is straight line. Reason? Let this be uniform electric field. Students, uniform electric field is represented by parallel and equidistant lines. Okay, straight, parallel and equidistant lines. Fine. So this is electric field E. If there is a charged particle Q and it is positive, then this experiences force in the direction of the field. So force on the charged particle is Q into E. But force from Newton's law, M into A. Observe these two. Acceleration equal to QE by M. QE by m. Now, direction of acceleration is same as the direction of electric field. So this is an equation in vector form. So direction of E is the direction of A. So there should be acceleration if direction of E is same, then direction of acceleration is also same. Means the particle continues to move in a straight line with uniform acceleration. Students, this is a trick, okay? Actually, it is not trick. It is a suggestion. Try to get the answer using equations. Every time, whatever we think, just we think, doesn't gives the correct answer. Therefore, please depend on equations. A charged particle is placed in uniform electric field. Its path and nature of motion will be charged particle in uniform electric field. It's a straight line. This is uniform electric field. Charged particle plus this experiences force in the direction of the field. Therefore, F equal to Q into E. The direction of electric field is the direction of force. If there is force, then there should be acceleration. This is straight line and acceleration. So straight line with uniform acceleration. A proton perpendicularly enters a uniform electric field. The trajectory of the proton is parabola. Okay. Observe. If this is the electric field and a proton which is positively charged enters this electric field perpendicularly with velocity say u, then this proton experiences force in this electric field. As a result, it gets deflected like this, because every time the direction of force will be in the direction of the electric field. So this is electric field and this is force. This is force and path is a parabola. Suppose the proton enters the electric field parallelly like this, then path is a straight line, because force is in the direction of electric field. So this continues to travel like this, perpendicularly parabola, parallelly straight line. Now let us see why it is parabola. Let this be uniform electric field. Length of the electric field is x. Okay. A proton positively charged, let it enter this uniform electric field with velocity u. So u is initial velocity in this direction. This is the initial direction. Because of force in the direction of electric field, it is deflected like this. So force on a charge in electric field is Q into A, which is equal to M into A. Therefore A is QE by M. So we got expression for acceleration. Speed equal to distance by time. So time equal to distance by speed. Speed is u. Okay, speed is u. So we got the expression for time during which the proton covers displacement x in the horizontal direction. Fine. Now, I want this displacement. This displacement is along y-axis, so let me denote it by y. Now, s equal to ut plus half at square becomes this is displacement in this direction, which is denoted by y. Initial velocity in this direction is 0 because velocity is along the horizontal, plus half acceleration is QE by m into t square. T square is x square by u square. X square by u square. Observe, displacement is proportional to x square. Displacement is proportional to x square, and this represents a parabola, isn't it? Parabola. That is why path of a charged particle entering a uniform electric field perpendicularly is a parabola. A metallic solid sphere is placed in a uniform electric field. So this is the electric field. Metallic sphere, and this is the electric field. Which path the lines of force follow? Inside the metallic sphere there is no electric field. Okay, we know that concept. So it could be first or fourth because inside there is no electric field. So we should decide between first and fourth. This metal sphere is polarized because of the electric field. As a result, shape of the electric field changes. Shape changes means here the shape changes. It is attracted towards this metal sphere. Therefore, fourth option is appropriate. Fourth is there in fourth option. Therefore, 4. An electron is revolving in a singly ionized helium ion. The electrostatic force between them. Now, singly ionized helium, hydrogen, helium. So helium has 2 electrons, 2 protons. Singly ionized means 1 electron is removed. Therefore, only 1 electron is left. So it is the attraction between electron and the proton. From Coulomb's law, force is inversely proportional to square of the distance between them. Therefore, F is proportional to r power minus 2. If both the charges and distance between them is doubled, then new electrostatic force will be. So force is proportional to product of the charges inversely proportional to square of the distance between them. It's given both the charges and distance between them is doubled. Q1 becomes 2Q1, Q2 becomes 2Q2, R square. This is 2R whole square. Observe, Q1, Q2, 2, 2, 4, 2 square is 4. These are cancelled. So we are left with Q1, Q2 by R square, which is F. So F dash is equal to F. F dash is this force, which is equal to F. Means no change. 2 identical charges repel each other with a force equal to 1 milligram weight when they are 0.6 meter apart in air. G is given. The value of each charge is. Fine. So force equal to constant Q1 Q2 by R square. Okay. Force is 1 milligram weight. 1 is 1. Milli is 10 power minus 3. Gram to kg, another 10 power minus 3. Kg weight to Newton into 10. Acceleration due to gravity. Constant is 9 10 power 9. two identical charges, q into q, q square, by distance is 0.6 square. Now q square is 0.6 square by 9, 10, 10 power 9 is 10 power 8. This 10 power 8 goes to numerator, becomes 10 power minus 8. Minus 3, 10 power minus 6. So q equal to square root of this is 0.6. Square root of 9 is 3. 10 power minus 4. 10 power minus 3. 3, 1, 3, 2. So 0.2, 10 power minus 7. 2, 10 power minus 8. 20, 10 power minus 9. 10 power minus 9 is nano, isn't it? So 20 nano coulomb. Students, observe, you don't have to simplify this, because anyway you know that we have to take square root. Since we have to take square root, it should be 0.6 square. If it is 0.6 square, it is easy to simplify. Electric field produced by an electron at a point is E. What will be the electric field produced by lithium plus plus plus, that is lithium 3 plus, at the same point if it is placed at the position of electron? Hydrogen, helium, lithium. Lithium has 3 electrons, 3 protons. Lithium plus 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 means 3 electrons are removed. So lithium has only 3 protons, isn't it? Done. Now this is electron, point P, electric field is E. If electron is replaced by 3 protons, then electric field at the same point will be 3 times E. Because of one charge E, because of 3 charges 3E. Of course, directions are different. Because of negative charge, electric field is towards. Because of positive charge, electric field is away, isn't it? If this electric field is E, then this electric field should be minus 3E. Why minus? Direction of this is opposite to the direction of this. But look at the options. There is no negative sign in any of the options. Therefore, just 3E. And electric field is constant Q by R square. Electric field is proportional to Q. Electric field is proportional to Q. That is why for one charge E, for 3 charges 3E. If EAX and EEQ represents electric field at a point on the axial, so axial and equatorial line of a dipole. If points are at a distance r from the center of the dipole, for r very much greater than a. So this says that it is a short dipole. Short dipole. Okay. Now, if this is a dipole with minus q and plus q, center of the dipole, electric field at a point for a short dipole is constant 2p by r cube. 2p by r cube. At the same distance on the equatorial plane or equatorial line, electric field is constant minus p by r cube. What is the meaning of negative sign here? Direction of dipole moment is from minus q to plus q. So this is p cap. And the direction of electric field at this point on the equatorial plane is opposite. So these two are in the opposite directions. Therefore, this negative sign. Okay. And this is electric field at a point on the axis. This is electric field at a point on the equatorial plane. So we can write electric field at a point on the axis equal to constant P by R cube. Constant P by R cube is electric field at a point on the equatorial plane with 2 and negative sign. And in this case, plus is closer to this point. So influence of positive charge is more. Therefore, direction of electric field is in the direction of the dipole moment. Look at this. Electric field in the direction of dipole moment. That is why positive. These two are in opposite directions. That is why negative. Electric field at a point on the axis equal to minus 2. Minus 2 times electric field on the equatorial. The electric field at a point on the equatorial plane of a short electric dipole varies as equatorial plane. So this is the dipole. This plane is the equatorial plane. Electric field at a point on the equatorial plane is constant minus P by R cube. This is electric field. This is dipole moment vector. So electric field is 1 by R cube. 1 by R cube. Electric field is proportional to 1 by R cube. And distance of this point from the center of the dipole is R. Electric field at a point due to a point charge varies with distance as. This is a point charge Q. Electric field at some point is constant Q by R square, isn't it? So due to point charge, electric field is proportional to 1 by R square, or inversely proportional to square of the distance, 1 by R square. Why such relations are important means, suppose in some problem it is given as if distance is doubled. Distance is doubled means 1 by 2R whole square. So 2 square is 4. This implies that new electric field becomes E by 4. So to decide this number, you should note this relation. So that is why it is important to note the statement and the equation. An electric dipole consists of two opposite charges, each of magnitude 1 microcoulomb, separated by a distance of 2 cm. The dipole is placed in an external electric field, of 10 power 5 Newton per coulomb, the maximum torque. So torque is given by P cross E. So magnitude of torque is PE sin theta, and torque is maximum if sin theta is equal to 1. So it is P into E. P is Q into 2A, and this is electric field. So charge is micro minus 6, 10 power minus 6. Distance between the charges 2 cm, and then electric field is 10 power 5. So it is 2, 10 power minus 6 minus 2 minus 8 plus 5 is minus 3. So this is the torque, which is Newton meter. So So 2 10 power minus 3. A point dipole is located at the origin in some orientation. The electric field at the point 10, 10 on the xy plane is measured to have magnitude 10 power minus 3 volt per meter. What will be the magnitude of the electric field at the point 20, 20? Electric field is inversely proportional to cube of the distance. 10 centimeter to 20 centimeter means distance is doubled. Distance is doubled means 1 by 2r whole cube. 2 cube is 8. Therefore, new electric field is 1 by 8 times the electric field at 10 centimeter. 10 power minus 3 by 8. Observe the options. 1 by 8 is 0.125. 10 power minus 3. So 0.125 is here. If you rearrange, you will get 1.25. Now understand this little bit. If this is the coordinate axis, 10, 10. Here is the point P. Okay. Distance of point P from the origin is 10 root 2. This point is at 10, 10. Therefore, length is 10 root 2. In the second case, the distance becomes 20, 20, 20, 20, 20. 20, 20 means the new distance will be 20 root 2. See, earlier distance 10 root 2. New distance is 20 root 2. 10 root 2 to 20 root 2 means 2 times the radius, 2 times the distance. That is why it is 2r. Students, understand? The problem appears to be big and level 2 problem. But actually, you have to take care of the distances. Since it is 10 and 10, 20 and 20, just distance is doubled. So, 1 by 8. Work done to rotate an electric dipole from theta 1 to theta 2 in an external uniform electric field is. Direct question. If this is uniform electric field, position of the dipole, if it is minus q and plus q, direction of dipole moment is from minus q to plus q. So this angle is theta 1. Initial position, initial angular position. If the dipole is rotated from theta 1 to theta 2, so this is theta 2. Then work done is given by P E, dipole moment, electric field, cos theta 1 minus cos theta 2. It is from initial to final, initial angular position to final angular position. You can also see equations like minus P E. Just take negative sign as common factor. You will get cos theta 2 minus cos theta 1. So if it is minus, initial, final. If it is plus, initial should be first term, final angular position should be second term. Okay. Since it is mentioned theta 1 to theta 2, theta 1 to theta 2, there should be positive sign here. Theta 2, theta 1, negative sign. So it is second option. An electric dipole is placed in a uniform electric field with dipole axis making an angle theta with the direction of electric field. Fine. The orientation of the dipole for stable equilibrium. This is the applied electric field, uniform electric field, minus Q plus Q. So direction of dipole moment is from minus Q to plus Q along the line joining the charges. So this is P cap. Here force on minus Q is opposite to the electric field. Force on plus Q is in the direction of the electric field. So this position where theta equal to 0 is said to be stable equilibrium. Because the dipole is pulled on either side like this. Now, if this is minus Q and this charge is plus Q, direction of dipole moment is from minus Q to plus Q. So this is P cap. So angle between P cap and E is 180 degree. So theta equal to 180 degree. Minus Q experiences force against the direction of the field. So this is F. Plus Q in the direction of the field. This is F. Something like this. On this end, force is towards left. On this end, force towards right means something happens, and if the alignment changes, then the dipole will flip. So that is why this angular position is said to be in unstable equilibrium. It is equilibrium but unstable. So this is unstable equilibrium. This is stable equilibrium. So the orientation of the dipole for stable equilibrium is 0. Potential energy of an electric dipole in an external electric field is, this is also a direct question. Potential energy is equal to minus P dot E. Potential energy is a scalar quantity. If it is a scalar quantity, then it should be dot product. So cross product, decide between these two. And potential energy is always with negative sign. So you might have seen this negative sign in derivation, isn't it? So potential energy is minus P dot E. Minus P dot E. An electric dipole of dipole moment P is aligned parallel to a uniform electric field. The energy required to rotate the dipole by 90 degree is. Observe the options. Dipole is rotated in electric field, therefore it cannot be infinity. And energy is product of P and E. Observe, these two are not possible, therefore it should be this option. Now let us try to get energy equal to P into E. Okay, this is an external electric field, uniform electric field, and this is the dipole. This is minus Q plus Q. Direction of dipole moment is from minus Q to plus Q along the line joining the charges. Dipole is aligned parallel to a uniform electric field. So here P cap is parallel to uniform electric field. That is why I have kept dipole in this fashion. Okay, done. So here angle between P cap and E is 0 degree. Therefore theta 1 equal to 0 degree. It is rotated from this position to 90 degree. This position to 90 degree means theta 2 equal to 90 degree. Energy required or work done is PE cos theta 1 minus cos theta 2. This is initial angular position, final angular position. Theta 1 is 0, theta 2 is 90 degree. Cos 0 is 1, cos 90 is 0. So it is P E. So energy, E dash is energy, E is electric field. So energy required is P into E. Always try to get answer using equations. Okay. Of course, among these four, we can guess that this is the option. But how it is PE, why not it is minus PE, and why not it is half PE means we have to depend on the equation.